So today is incident response and the attack matrix, and the first part is Splunk. And this is very easy, and you could easily spend the whole morning on it, and we may very well. So if you go here to the very first one, Splunk Boss of the SOC, this is a training tool prepared by the people at Splunk. And all I did was add some hints to make it a little easier and stick it in my scoring engine. And you don't have to install anything because Splunk is actually, you'll do it later, installing Splunk to get actual enterprise class data is pretty big and expensive job. And here, what I did was I took their data set and I put it on some cloud servers so you can use it. So I got a couple of servers here, and you log in as student 1 with a password of student 1, and you'll end up here. There's 2 servers that are the same for all practical purposes, just so in case they get busy. And the point of Splunk is supposed to be Google for log data. That's the idea. So you can just search for things through the data. And as you see, there's about 1 million events indexed from 5 years ago to just 4 minutes ago. And that's this. All right. So all the data we really care about is the data 5 years ago. So let me, all right, first let's talk about what kind of data is on Splunk. The point of Splunk is you take the logs that are picked up by all your devices, your firewalls, your servers, everything, and you forward them to one place. So you can search all your logs in one place. If you go to the data summary, it'll show you what you've got. They show it to you by host name, which are names of devices defined by your company. And I see why there's extra data. Somebody's been doing Splunk homework on here, but it won't really matter. Anyway, source types is here. And so you see there's some Windows event logs. There's some registry information from Windows. There's some FortiGate events, which is from a firewall, FGT. There's Nessus events. And there's stream data, which is data sniffed right off the wire. It does not capture entire packets, but it makes log entries summarizing things like DNS and HTTP traffic. And down here you have Suricata, which is an intrusion detection system, an open source one. So it detects known attacks. And then syslog, the Linux syslog, which I think, that's another one that's not really part of what we're going to search today. But anyway, there's the types of data you have. And now you can just search through it. So if you go to index equal bots v1, in order to make your Splunk server more efficient, you are encouraged to index data when you configure it. And especially in this case, where some student has added some extra data that really shouldn't be there, it's just as well to see how to index. So if we do that, now if we search for index equal bots v1 and run the search, we're going to find nothing, I would think. All right, that's interesting. They had managed to add some new, nothing much, because all the interesting stuff was years ago, and by default, it only searches the last 24 hours. So we have to change that to all time. And now, it's going to take a while to find it. Now, one thing that is really strange about Splunk is that the time it takes is determined by the number of answers, not by the amount of data it hunts through. So it's going to find about 1 million hits here. And that's going to take a while. So when you're just starting out, it's a lot better to do an event sampling, like 1 in 100. And then it'll be much faster. It's only going to show you a randomly chosen 1% of the data. But when you're looking through a large data set just to try to understand what's there, it's best to start with sampling so the server will move faster. It's still searching. This number is still changing, and still you see a check mark appear here. So even at 1 in 100, it's taking maybe 10 or 15 seconds. Oh, there's the check mark. Okay, so it found 11,000 events, which would really be 1.1 million. And as you can see, most of them are back here in 2016, and there's a few recent ones, and the ones we care about are the ones back here in 2016. All right, so we looked at the source types already and talked about what they mean. And so now let's look at HTTP events. So this is source type equals stream HTTP. Now I could type this in to the search box. I could also use the source type from, I'll just start by typing it in for now. That's fine. You can do everything by typing in queries here. And all you're really learning is sort of a query language for log data like Google Advanced Search. But you can also use the mouse to choose off of options. So here we go. This, all right, I think it'll be fine. All right, so now we've got some data here. And here's the stuff in 2016. Okay, so here you see what an event is. Now what happened is it says it found 221 events. Each event is a log entry. So here's what this log entry looks like. It's got a lot of HTTP data. This is the destination content, looks like a ping image. So it sent some kind of ping image. Here's the HTTP request that asked for that, or that's the destination headers. Someplace down here is going to be source headers. Here's the request, get favicon. So this is part of loading a web page. This looks like ordinary traffic. In fact, it's going to bing.com. Somebody took a web browser and went to bing.com. That's what you're seeing here. There's another one all full of Unicode and such. Anyway, all right, there's various events there. Now, you can find the fields. As you can see, there's a lot of fields here, like accept and bytes and CIP. Over here, at the top left, it has chosen some fields that seems important to it. And at each number, it'll show you how many different values there are of that field. So this is the client IP address of these web requests. If you click on that, it will show you the values. In all this data, there are only 4 different client IP addresses, and most of the data comes from this one, 40, 80, 148, 42. It tells you how many of each time, how many times it's seen each of these things. So if I wanted to know, like, what is this one, 192, 168, 250, 100 doing, if I just click on that, it will add that to the query. Client IP equals that. And now I see only 7 events coming from that source. And I can examine them. Now this is very much like Wireshark. You can examine them one by one here, or you can go over here and get summary information. So these are the selected fields that Splunk generally thinks are important. Here's fields that have an interesting range of values, and then there's a lot of other fields down here. So you can use the mouse to focus in on your query, or you can just type in queries in text. All right, and so now this website, for this demonstration data, they made a website called I'mReallyNotBatman.com. And so I want to search for HTTP events going here, so I just add that to the field. Now, the Splunk engineers don't like this, although I like doing it this way. If you can search just like Google, I can just put in a word without putting a field name equals word. See, source type equals stream will look in the source type field for that value. And Splunk engineers like that because that is really fast. But you can also use it just like Google. You can put in just a word, and then it will look for any event that has that word anywhere in the event. Just the way Google would, just a keyword match. And often it's good enough. So this tells me that string appears somewhere in the event. Now in practice, if it's an HTTP request and it has that string, it would of course be in the domain name, in the host name that's requested, but I didn't bother to figure out what field it was in. Anything that has that string anywhere in it will appear. So here it is, host, I'mReallyNotBatman.com. That's where it appears. So this is a request. All right. So this is a request to the server. And if I look at HTTP requests with that domain name, these are all legitimate requests from customers coming into my web server, or at least maybe not legitimate, but they are requests that went to my web server because nothing else would have that domain in it. So here's a post. Apparently the web server is running Joomla, and this looks like it's getting a search page of Joomla. They got a moved response, object moved. It's a 303 moved. And I'm just looking to see if there's anything fishy looking about these events, because you usually don't have to look too far in this data set before you find something fishy. And look, here we are, referrer, cookie, encoding. This all looks like a normal web request. It's not. This is what I was looking for. This is a vulnerability scan right there. Acunetics product. Acunetics Web Vulnerability Scanner. The attackers started by running a vulnerability scanner. And a vulnerability scanner, if you actually just get a pirate copy of the vulnerability scanner or a free version, and you don't even modify it, it will mark every request with the brand name of the vulnerability scanner because they do not intend you to be a criminal. They intend for you to be an official, pen testing company scanning a site or something, or a part of a company checking the security, and they want to make sure and mark this so anybody that gets confused by this funny traffic will understand what's happening. So these guys used that scanner to scan this site. And having found one of these, you can now answer the first several flags, which are, what's the name of the vulnerability scanner? We just saw that. And now, if you want the attacker's IP address, you just find the source of anything that's marked scanner. So here's the source IP. That must be the attacker's IP address, 40.80, because they're sending traffic that's marked vulnerability scanner. And the web server's address has to be the destination address of this. So you'll find that too in any of these. And then, now we can try to find the defacement file name. Now what happened is, this is where, I love this because this shows you why people pay vast amounts of money for Splunk. You can easily end up paying $500,000 per year for your Splunk license. If you install the free version of Splunk, you can totally, that's what I'm using now, it's totally functional, but you can only examine old archived data. You're limited in how many megabytes per day you can examine of new data. And you pay by the amount of data you analyze. And companies cheerfully pay vast amounts of money to get Splunk because it makes it very easy to answer important questions. So here's an interesting question. I now know the web server's IP address. It was the destination of this request. Good morning. And so what I want to do is I would like to see if there's any traffic that goes backwards on the network. So this is my destination address. I'm going to copy it. And now I'm going to get all the HTTP requests. But I'm not going to have this I'm really not Batman in it because I'm looking, see what's happening is in a properly designed network, your server is only allowed to be a server. You have a web server and requests are coming into it, but nobody is supposed to open a web browser on the web server and surf to a page and start downloading things. In fact, if you install a server version of Microsoft Windows, it will not let you open the browser and download things on a server. You're not supposed to be doing that. If you want to put a file on the server, you're supposed to download them on a client machine, scan them for antivirus, and move them over with a file share or something. There's two reasons not to do that. The first one is you might get your server infected with malware. But the second one, probably more important one, is this is how criminals will compromise your server. They will execute code on your server. They find some kind of vulnerability, lets them execute code, and then they will try to make a reverse shell that sends a traffic signal back from the server to the command and control center to maintain control of the server. And you don't want to let that happen. So the way you prevent that is you do not let your server send any requests going out. It answers requests coming in, but it can never initiate a request going out. So the question here is, did that happen? If that happened, that means this network is not using routing and firewalls correctly. And it also means something really wrong is going on the web server. So right now, I found this address, which I put in the clipboard. This 192 address is the address of the web server, and I want to see if there's any traffic with that as the source address. So I'm going to search all the HTTPs again, with sampling turned on, so it'll be pretty fast. And then I'm going to look at the client IPs here, and I'm going to pick one of these just to get the syntax right. And then I'm going to paste in the address from my clipboard. So now I'm going to find traffic that came from that IP address and was HTTP. And I didn't find any, but that's because of my sampling. Now, if I turn off the sampling, I'll really search all the data, and I should find just a few of these. There's one, I think there's about 7 or 8 of them. There are 9 events. These are events of traffic going in the wrong direction, where the web server is acting as a client instead of a server. And these are malicious events. These are important events. These are the events, what happened is the criminal did gain code execution on the server, and then they downloaded a file to deface the web page. And since there's only 9 events, I can just look at them one by one and see what happened here. And right here, I see get poison ivy is coming for you, batman.jpg. That's the image they used to deface the server, a JPEG image. and I can find the domain name they went to get that. They also has a funny port number, 1337, which is, a common joke name used by hackers. And there's the GET request, and here's the funny host name they used, prankglassingbracket.jumpingcrab.com. So they made a suspicious domain on a suspicious port. They downloaded a suspicious file and put it on the server. And the reason people pay so much for Splunk is this was not hard to do at all, to hunt through 1 million events and quickly find the 9 that are suspicious. And that's the heart of incident response. It's hunting through this stuff. So give it a try, do some of these, and I'll come back and demonstrate these a little later, but you should be able to find several flags by now.